同學呢段片就會講返 Lesson Quiz 12 Trigonometric Functions 嘅一啲題目講解。咁如果你係對某一條特別想知道返點做，就 feel free 去飛去嗰度去聽啦。咁我哋先開始啦。咁啊，第一條題目個 key point 就係你可以用計數機啦去 check 到1減開方3係細過0嘅，which means that sin theta is negative, which implies that theta must lie in quadrant 3 or quadrant 4. Therefore, the answer is D. It is relatively easy. So for question 2, we have two angles. The first one is alpha. From the information provided, we know that sine alpha must be greater than 0, while tangent alpha will be smaller than 0. The second condition is beta lies in quadrant 4. It means that tangent beta has to be negative and cosine beta will remain positive. So the combination sine alpha multiplying tangent beta must be negative, and the combination cosine beta over tangent alpha is also negative. So both statements are wrong, and therefore the answer is D. So for question 3, the trick is that you realize the angle provided within the range is 3 theta, so you have to divide the whole range of 3 theta by 3 to obtain this result. And basically, theta will be lying in quadrant 4 for this range. Okay, it represents a quadrant 4 angle of rotation. So in quadrant 4, sine theta is negative while cosine theta is positive. So the first statement is correct. Now for the second statement, we know that sine theta is negative while tangent theta is negative as well. So the addition of any two negative number must remain negative. So the second statement is correct as well. So let's move on to question 4. Again, we have alpha and beta. So let's discuss one by one. Sine alpha must be greater than 0 in quadrant 2, and cosine beta must be smaller than 0 in quadrant 3. So you see that we are trying to subtract a negative value from a positive value, which must return a positive value. The first statement is correct. Now for the second statement, we know that tangent beta is negative. So now you are trying to have a negative number minus a positive number. It must give you a negative number. So the second statement is incorrect. Therefore, the answer is A. Now, let's move on to question 5. You can see that we have an angle of rotation within tangent, and therefore, you need to simplify tangent theta minus 360 degree before we start. What is negative 360 degree? It means that you rotate clockwise, and then you add theta, so the result will be within quadrant 1. Since this is a quadrant 1 angle of rotation, it means that after the simplification using identity, we obtain the result tangent theta equals to negative square root of 33/4. Okay, so we apply the identity and obtain this result. Now since tangent theta is negative, it means that theta lies in quadrant 2 or quadrant 4. Together with the information that cosine theta is negative, it means that you have to choose quadrant 2. So now we draw the triangle in quadrant 2. So theta, and draw the corresponding right-angled triangle. It will be positive 33 of the square root for the vertical distance and negative 4 for the horizontal distance. And by Pythagoras theorem, you know that the length of the hypotenuse will be 7, and therefore sine theta will be positive square root of 33 divided by 7, which gives you the answer C. In quadrant 2, sine theta must be positive. Okay, so now we are in question 6. It is a very similar question, and we can easily conclude that theta has to be lying in quadrant 4. This is not difficult to claim this result, and this is 2, this is 3, and obviously the vertical coordinate will be negative square root 5. And therefore, we know that sine theta will be negative square root 5 over 3, and tangent theta will be negative square root 5 over 2. And the required result will be negative square root 5 over 3 minus negative square root 5 over 2. And what you have to calculate is 1 over 2 minus 1 over 3 and multiply square root 5, which suggests that the answer will be 1 over 6 multiplying square root 5, and the answer is B. Alright, so now let's move on to the second page for question 7 and move on. So by remembering the identity, the first one will be sine theta, tangent 225 degree. By using reference angle, the reference angle is 45 degree. The angle lies in quadrant 3, sorry. So therefore, it remains positive. So it is basically 1 in the denominator. You see that you have a 270 degree. So the ratio has to be changed. 270 minus theta lies in quadrant 3. For cosine ratio, it returns a negative ratio. 330 degree. The reference angle is 30. But this is an angle in quadrant 4, so you have to add a negative sign. And therefore, the second denominator will be negative 1 over 2. You have so many negative signs, so let's handle them one by one. Let's cancel both of them on the numerator and denominator. And what you get is sine theta minus 2 sine theta, and therefore the answer is A. So question 8. By using identity, the first ratio right here will be sine theta together with a negative sign, since this is a quadrant 4 angle. While for the denominator, 180 degree represents that the ratio do not need to be changed, but a negative sign has to be added. So let's fast forward. It will be negative cosine theta, and the reference angle of 300 degree is 60 degree. In quadrant 4, it means that cosine remains positive. So let's have 1 over 2 in the denominator. Again, you have 2 negative signs right here for an MC question. Basically, we use an eraser and remove it. And you can basically do something like this. So 3 sine theta over tangent theta So this is basically cosine theta over sine theta by using identity, and what you obtain as the final answer will be B. Quite obvious. So question 9. The first step, let's simplify the identity again one by one. So the negative sign, and let's consider what should be the result after using identity to be squared. 180 degree ratio remains cosine plus theta lying in quadrant 3, so you have to add a negative sign. So similar logic. The first ratio and the second ratio. Okay, you can check one by one if you get this wrong for the ratio for each of them. So for the numerator part, this is the simplification. For the denominator part, you have two negatives resulting in a positive ratio, and therefore what you obtain will be cosine theta over sine theta. This is basically the same as 1 over tangent theta together with a negative sign indicated here. Therefore the answer is B. For question 10, now this is a little bit more challenging. If alpha lies in quadrant 4, so you expect that cosine alpha is positive. You expect that sine alpha is negative. Now we have some identity to be applied again. This component that I have enclosed it by using identity. Okay, so ignore that alpha is lying in quadrant 4 right now. To remember the identity, basically you do not care about the size of alpha. What I have labeled here will be identically equal to negative cosine alpha for any alpha. I repeat, for any alpha. So when you think of the ways to remember the identity, actually you assume that alpha is an acute angle. However, the identity result is actually applicable for any alpha. But for simplicity, you remember it by basically trying to understand the quotient for an acute angle and extend for any angles. And therefore, actually, the first statement would become cosine alpha plus 5 cosine alpha. Since you have a negative sign right here after applying the identity, and it will give you a positive sign. So 6 cosine alpha must be positive since alpha lies in quadrant 4. So the first statement is incorrect. Similarly, for the second statement, sine alpha plus 5 70 degree means that the ratio has to be changed, and you have to add an arbitrary negative sign. And then you simplify sine alpha minus 5 cosine alpha. So you know that sine alpha must be negative, while cosine alpha component in quadrant 4 must be positive. It means that you are subtracting a positive number from a negative number, so it must remain negative. So the second statement is correct, and the answer is therefore B. Now for question 11, it tests your understanding on identity. So for the first one, 630 degree is actually 360 plus 270. So in terms of angle of rotation, it is stopping right here. Oh, wait a moment. This is not appropriate, since actually we are trying to simplify theta minus 630 degree. It means that you have to count in the negative rotating direction instead. So let's do this again. So negative 630 means that after rotating clockwise around, you rotate further clockwise 270 degree. This is the meaning of negative 630 degree, and you add theta. So the result will be lying in quadrant 2, and the axis will be on the y-axis for the reference triangle to be constructed. So what do you expect for quadrant 2 is that sine remains positive. It will not give you the negative sign, although the ratio has changed to cosine theta, and therefore the first statement is incorrect. The second statement is similar. So plugging in n to be the negative 270 degree, we are trying to simplify the identity like this, and it really rotates anti-clockwise for 270 degree. You further add theta, the result will be lying in quadrant 4. The ratio has to be changed since the reference angle lies on the y-axis instead of x-axis. And in quadrant 4, only cosine is positive, so the second statement is correct. So the answer is B. Question 12 is still very similar, but the form that the question provides you is a little bit different. Basically, if you try A equals to 270 degree plus 2B, you will realize sine A replaced by the form 270 degree plus 2B will be identical to cosine 2B adding a negative sign. So the first statement is incorrect. So I believe that the second statement is easy for you to go through. I'm not going to discuss. For question 3, please pay attention. It should be a multiplication sign instead. There was a typo, but let's focus on the multiplication sign scenario here. So let's simplify the identity one by one, and then you can change the second fraction into 1 minus sine theta over cosine theta. And by using identity difference of square identity and further change this into cosine squared theta would give you the result cosine theta over sine theta. And the answer will be D. This is a relatively easy simplification. While question 14 is slightly more difficult. Again, I'm not going to derive all the identity results one by one. I will just write down the answer. You can follow one by one. And then you will see that the answer will be cosine theta minus sine theta over 1 minus tangent theta. Okay, so this is quite interesting, because if you want to further simplify, in fact you have to change tangent theta into sine theta over cosine theta, in the sense that you will write the 1 in the denominator into cosine theta over cosine theta. The reason for doing this is that you will see that you are trying to divide cosine theta minus sine theta over cosine theta by the numerator, and therefore if you write one more step handling the complicated fractions, you will see that cosine theta minus sine theta can actually be eliminated or cancelled out by each other to get the answer B. This is quite an interesting question. Okay, here comes the most challenging page that I think most of you would like to understand more. Okay, for question 15, there should be a square root sign right here. Okay, so question 15, since this is a negative ratio together with cosine theta to be greater than 0, we know that angle theta lies in quadrant 4 and you should expect tangent theta to be negative, and therefore you should only choose C or D. Okay, so for the triangle, I'm going to use the reference angle, which means the angle is to be an acute one using alpha instead of theta to avoid drawing the quadrant diagram. So sine alpha will be square root 3 plus square root 2 over square root 10. So the x value will be calculated by the square root of square root 10 squared minus the hypotenuse to be squared. Okay, it involves relatively more tedious calculation, but you should finally obtain something like this. But this is not the end of the story, because you are trying to find tangent theta, but not just 5 minus 2 over 2 times square root of 6. So as if you remember in chapter 1, we have a question simplifying this kind of compound surd, or you may say that this is a quadratic surd. 5 minus 2 square root of 6 is actually square root of 3 minus square root of 2 to be squared. You can verify this. Let's do this right here. It will be 3 minus 2 square root of 6 plus 2, and therefore you should return square root 3 minus square root 2 for the length of x in a very neat and tidy way, such that the tangent theta that you are searching for, the value will be provided by this ratio. Of course, you have to add a negative sign at the end, since theta is a quadrant 4 angle. But to simplify this, you have to rationalize by multiplying the purple fraction. Now you realize the denominator will be square root of 3 to be squared minus square root of 2 to be squared, which gives you basically 1. And for the numerator part, you will observe that it is 3 plus 2 square root 6 plus 2, and therefore you obtain negative 5 plus 2 square root 6 over 1 as the denominator, and you ignore the 1 and see that the answer will be D. It involves more calculation and simplification in terms of surd. So this is a relatively challenging question. Therefore, I placed it in question 15. Question 16 is very standard type question that you must understand in order to achieve in your public exam. It always occurs in paper 2. So we try to link up AD and AB. So AD is right here, AB is right here, and therefore the connection between them must be AC. And therefore you will write cosine alpha equals to AB over AC. Let's express the connection AC in terms of AB and cosine alpha, and we move on using sine beta to connect our target AD and the connection AC. You see that AD will be AC sine beta, and therefore AD over A boy. So A boy is AC cosine alpha. The AC as the connection will cancel out each other to give you the answer B. Question 17. So one of the major point right here is that we know the opposite angle within the kite will be the same, also to be theta. So this can be proved by drawing a line connecting AC. So the triangle on the left hand side will be congruent to the triangle on the right hand side, since AC is the common side. Basically, this is the result of SSS. Of course, you may say that this is property of kite, but the point is, after you're adding up the angles together within the kite, they have to be summed up to be 360 degrees by angle sum of polygon, and therefore phi will be 270 degrees minus 2 theta. So if you insert a sine ratio, you are trying to simplify this using identity. First of all, the ratio has to be changed since it is 270 degrees. Subtracting something means that it lies in quadrant 3, so you have to add a negative sign. Therefore, the answer is D. Okay, question 18 is supposedly the last question in our lesson quiz, excluding the bonus question. It is a relatively challenging question, I would say. So I will give you some hints. If you treat sine theta to be alpha and cosine theta to be beta, so one fact that you have to know and you must know is that alpha squared plus beta squared is 1. And now your target is to find alpha to the power 4 minus beta to the power 4 in terms of k. Now let's do a factorization which must come into your mind. And interestingly, the first bracket will be 1. So what will remain is alpha squared minus beta squared. And further factorization will give you something like this. And the first part will be k. But here comes a question. What will be alpha minus beta? Okay, so now alpha minus beta means sine theta minus cosine theta. Since we have the range that theta lies between 45 degrees and 90 degrees, sine theta must be greater than cosine theta. It must be greater than 0. And if you remember, so the reason why I use alpha and beta is that I hope you would recall such a formula. It is a very common skill when we handle quadratic equations. And you know that alpha squared plus beta squared is actually 1. So you can simplify as 1 minus 2 alpha beta. The story still needs to be proceed because we do not know what is the product of root. So how can we obtain alpha multiplying beta? Again, we move backward to the fact that alpha plus beta is equal to k. If we squared both sides, we will see that this will be k squared. But you have again, let me circle in red color, these two adding up to be 1 plus 2 alpha beta equals to k squared. Alright, and then you will obtain 2 alpha beta to be equals to k squared minus 1, and therefore the purple square root can be further simplified as something like this, to be equal to 2 minus k squared, and therefore the answer is D. This is a question combining trigonometric ratios, identities, and also some previous knowledge when you try to handle the algebra in quadratic equations. Alright, here comes to the bonus questions. Question 19 requires you to draw the graph by yourself. So you have a trapezium. Okay, we need to draw a trapezium. Let's draw this arbitrarily. We know that it is a right angled trapezium, maybe A, B, C, D. So we can satisfy AB parallel CD. Great, a good job. But we need angle BAD to be 90 degrees. It is not 90 degrees. So we want, if we remain AB on the top, CD at the bottom, let's say, we should expect that the alphabet has to be changed a little bit. That AB lies in the direction like this and CD like this in order to generate the 90 degree. So M is a point on AD such that MB will bisect angle. So this angle has to be bisected, and obviously you see that it is a little bit strange, so you have to modify the diagram a little bit. Maybe we expect something like this, and let's tune the size or the position of C to make it a little bit nice looking. And in fact it will be better that the angle will be greater than 45 degrees. It will look slightly nicer for these two angles to be the same. And also it requires that M be perpendicular to MC. So now you try to create a right angle. So actually drawing an accurate diagram requires some skill that you have to figure out by yourself. And more naturally, now I will place B right here, A right here, and let's draw a longer side for angle for the position of M, and draw a right angle and draw something like this for these two angles to be the same size, such that you can now connect these 2 points and claim that this is C, this is D. Alright, so you can see that if you want to draw a relatively nice looking diagram, you need some practice and you need some trial and error before you can draw a good diagram. It requires some of the skill. Okay, so here we see that these two angles have to be the same. Let's claim that they are theta. You know that by angle sum of triangle, this is 90 degrees minus theta, such that this angle on the right hand side will also be theta. So we want to find the length of MD. Let's suppose the length of MD is L. So in triangle MCD, you can see that cosine theta equals to L over MC, and MC will be equals to L over cosine theta. And if we further consider triangle MBC, now we are trying to connect the blue line and the red line. So tangent theta will be equals to MC over MB, and MB will be equals to MC dividing tangent theta, which means that multiplying cosine theta over sine theta equals to L over sine theta. Lastly, we consider in triangle AMB. So now if we multiply sine theta ratio equals to AM over MB, you will see that AM will be equal to L over sine theta multiplying sine theta, which suggests that AM must be of equal length with MD, which is also L. And since AD equals to 8 cm, you basically know that M is the midpoint of AD, and therefore the answer is A. Actually, the length 10 cm on top is redundant. You do not need this information. So really the last question, question 20. So you have to label some of the angles first. So let's do this one by one. This is phi, this is theta. You have this to be 90 degree, this to be 90 degree, and this to be 90 degree too. So our target is to express tangent phi in terms of theta. And we have an important fact that AB equals to CD. So if we let the length of DE to be L, you should expect AE in terms of L and theta, CE in terms of L and theta, and lastly BE in terms of L and theta. And then you can use the result AB equals to CD to link up tangent theta and tangent phi. Let's do this one step by one step. Before that, I would like to claim that this is 90 degree minus theta, such that the angle on the left hand side is theta as well. So in triangle ADE, okay, so you see that tangent theta will be equal to AE over L, and AE will be L multiplying tangent theta. So in triangle ACE, you should expect that again tangent theta equals to CE over AE, such that CE equals to AE multiplying tangent theta, and AE is L tangent theta, and giving you L tangent squared theta. In triangle BCE, you should expect tangent phi equals to CE over BE, and therefore BE equals to CE over tangent phi. And you expect that the important way connecting them is AE plus EB equals to CE plus ED, and we place in the ratio one by one. AE is L tangent theta, EB is L tangent squared theta over tangent phi. Okay, let me write a little bit better to improve the mathematics. Let me change something like this. And equals to CE L tangent squared theta plus ED, which is basically L. So you can cancel out L. Altogether, you obtain tangent theta plus tangent squared theta over tangent phi equals to tangent squared theta plus 1. And let's do this quickly. You want tangent phi to be the subject of the formula, and therefore you will let tangent squared theta over tangent phi standing alone on the left hand side, and obtaining tangent phi equals to tan squared theta over that bunch of things. So the advantage, so you see that the final answer has to be in terms of cosine theta and sine theta. Now you have something in tangent theta. You have to change all the ratio into sine over cosine. The advantage is you will see very soon that is you have 3 terms right now in the denominator, but after you switch to sine ratio and cosine ratio, you have 2 terms in the denominator only. Okay, so let's do this very quickly. We change all the tangent squared theta and tangent theta into sine over cosine. Also, write the 1 right here in terms of cosine squared theta over cosine squared theta, since these two will give you the numerator equal to 1. So this is the numerator. Denominator will be 1 over cosine squared theta minus sine theta over cosine theta. And you multiply both the numerator and denominator by cosine squared theta, such that you will receive the final answer that tangent phi equals to sine squared theta over 1 minus sine theta cosine theta. Okay, this is a relatively tedious question, but I hope that you can learn something from this question.